Hello everyone, welcome back to another interesting case study. So this case study is based on a hint index underscore join. Now this is again similar to index underscore combine hint or the use underscore concatenate hint. So in index underscore combine hint, what Oracle does is there is an internally bitmap conversion. That is the access path which Oracle uses when you do an index underscore combine hint. Similarly, when you use a use underscore concatenate hint, there is a B-tree index access path. And of course, use underscore concatenate hint goes well with the or operations in the where part of the clause. So similar hint we are going to see today is index underscore join hint, which utilizes B-tree index access path rather than the bitmap index access path. So let's explore the index underscore join hint. So this is the select query, select count of star from employees E, comma departments D, where E dot job ID is equal to ST underscore man and E dot department ID is equal to 100 and E dot department ID is equal to D dot department ID. So now again, this is a join operation between the employees table and the departments table, and D dot location ID is equal to 1700. Now when I execute this query, I'm getting 0 rows. That means none of the rows are getting qualified when I run this where part of the clause. And this is the plan which Oracle has taken, and this is the access and the filter predicate information. So let's see how we want this query to be executed. So going by the fundamental approach, we should start with such a column in the where part of the clause which is qualifying for less number of rows or is having more number of distinct values. Now if you see e.jobid is equal to stman is qualifying for 6 rows. Okay, so this is a good column to start with. And e.department is equal to 100 is again qualifying for 6 rows, so which is also a good column to start with. But the number of distinct values of job ID and the department ID is not that high. Okay, so we'll explore this in the statistics view for the employees table when we go below. Okay, so once Oracle scans e dot job ID is equal to stman and e dot department is equal to 100, it is going to qualify for some rows, and these rows will be further joined with the d dot department ID. Okay, and the result of the join operation will be filtered for d dot location ID is equal to 1700, right? So this is how we want Oracle to execute this query. Oracle should access e dot job ID is equal to stman and e dot department is equal to 100. The result of this should go for the join operation with the departments table. Now let's see whether Oracle has actually executed this query. Now before exploring that, let's see select count of star from employees. When I run this query, is going to give 0 rows. So that means when Oracle access e.job ID is equal to stman and e.department is equal to 100, none of the rows are getting qualified, right? So this is one thing which we have to note it for now, and we'll see how we can utilize this information further. Now let's see how Oracle has executed this query. This is the execution plan which Oracle has taken, and if you create a parent-child relationship, this is the first operation which is getting executed. Right now, fourth operation is nothing but accessing the employees table for the job ID column where job ID is equal to st underscore man. So that means Oracle has actually accessed this e.job ID, which is actually we wanted. When Oracle accesses e.job ID is equal to stman, it is expecting 6 rows, right? And if you run this query manually, you're also getting 6 rows back. So once these 6 rows are accessed, then the third operation is being executed. So third operation is nothing but your filter operation on e.department ID is equal to 100. So what does this mean? So once Oracle accesses e.job ID is equal to stman, it is expecting 6 rows out of the access, and then it will go to each and every department ID for the respective job ID to check whether the department ID for those 6 rows are actually 100 or not. Right? It has to manually scan each and every row for the job ID is equal to stman to check whether e.department ID is equal to 100 or not. It actually isn't, so that is the reason why it is qualifying for 0 rows. So can this be improved further? I already have an index on e.job ID as well, and also have a separate index on department ID as well. So why not I utilize both of my indexes on job ID and also on the department ID to make this execution faster, right? The reason why I need this is because e.job ID is expecting 6 rows, so I have to go to each and every row to check whether e.department ID is equal to 100 or not. So is there really a need? No. Why? Because I already have an index on department ID. So let's utilize that index to unnecessarily go for table access by index row, right? That means unnecessarily scanning each and every row to check whether the e.department ID is equal to 100 or not. Okay. So after that, once the desired rows are fetched, seventh is the operation which is going to execute later. So seventh is nothing but your d dot department is equal to 100, which is nothing but your join operation. So once this join operation is done, it will filter out the sixth operation, that is nothing but d dot location is equal to 1700, right? So the point I'm trying to make here is, if I have a table with multiple columns, that is nothing but a job ID and department ID, and I have a separate index on both of these columns, not a single index but a separate index on both of these columns, I can make use of the hint index underscore join, so that one index can scan job ID, the other index can scan department ID, and make the query execute much faster, right? So this is what we are going to explore today. Now looking at the table statistics, if you see, job ID is having 19 distinct values out of the 107 rows in the employees table. So job ID is not that a good column to start with, but since I also have department ID column in the where part of the clause. Now department ID is again having 11 distinct values only out of the 107 rows. So this again is not a good column, but the combination of department ID and the job ID using an AND operator is going to qualify for less number of rows. So that is the reason why we are going to use a separate index on both of these columns. Now let's see the resolution. So the resolution is to use an index underscore join hint. Okay, and these are the two indexes which we are going to use. First index, either employee underscore department underscore ix, will be built on the department ID column. Employee underscore job underscore ix is built on the job underscore ID column. Now when I pass this hint just after the select clause, it is going to go for an index underscore join, which is nothing but accessing or using the index via a B tree access path, right? So let's explore this. So this is the execution plan which Oracle has taken after we put this hint. And if you go by a parent-child relationship, so fifth is the first operation which is going to execute, and then the sixth, right? Now fifth operation is nothing but emp underscore job underscore ix. So that is nothing but accessing the e dot job id is equal to stman. That means this part of the clause is accessed by Oracle first. The next operation is the sixth operation, that is nothing but index range scan on emp underscore department underscore ix. So sixth operation is nothing but again accessing the employees table for the department ID column, which is again equal to 100. So once these two rows are scanned, there is a separate view which will be created using a hash join, right? So this will give you some data rows, row source or data set. This sixth operation is going to give you separate data set or row source, and the result of this will be hash join to create a view that is nothing but your index underscore join view, right? So now this view will be going forward for the join operation with the departments table. So like I said, index underscore join hint uses a B tree index access path. So how can we confirm that? Using this index underscore range operation. So index underscore range operation, if you're seeing, it means that it has done a B tree access path, which is a default access path within Oracle uses. But if you use an index underscore combine hint, in this case, you will see a bitmap conversion of row ID. So this was about using index underscore join hint. So the purpose is to use separate indexes on separate columns as one index to make the query run faster. If you have a composite index on job ID and the department ID, then that composite index is going to perform way too faster than the index underscore join hint, because there is no hash join operation being performed. But if you don't have a composite index, or if you have a separate index on different columns, then you can make use of index underscore join hint, or make use of multiple indexes in the where part of the clause which access multiple different columns. So that's it for today. I hope you like this case study. Please feel free to share your comments, and please don't forget to subscribe my channel. Thank you so much.